Hello students, this is session for NPS Grade A and B, which is continuation of your Mahamarathon. There was a technical glitch in Mahamarathon, so we are recording this and providing it for you. So here we will discuss important question of statistics. So first question is about coefficient of relation and coefficient of regression. Coefficient of relation and regression, how they are related? Coefficient of correlation. Coefficient of correlation is equal to bxy, that is coefficient of regression x on y into coefficient of regression y on x. So remember two things. The sign of this bx on y, here it is given mu, and mu y on x will be same as the coefficient of correlation. So our answer will be root coefficient of x on y, coefficient of regression x on y into coefficient of regression y on x gives you a coefficient of correlation, So answer will be B. Your answer will be B, and the formula will used will be R is equal to B x on y, coefficient of regression x on y, and into coefficient of regression y on x. Second question is about your probability, and it is about binomial distribution. We use binomial distribution where we have discrete data and we have two outcomes, like coin toss. So coin toss, like coin toss. Here you can see there is given that there are 6 tosses and you need to reject null hypothesis. And what is null hypothesis here? That probability of getting a head is 0.4 and alternative hypothesis is probability is 0.6. In binomial distribution, the probability is given by for example, you have n number of tosses. So probability mass function will be n c0, and you have probability of getting head is p and getting tail is 1 minus p, because these are mutually exclusive events. So nc0 p raised to power n 1 minus p raised to power 0 plus nc1 p raised to power n minus 1 1 minus p raised to power 1. In continuity, it will be up to ncn p raised to power 0 and 1 minus p raised to power n. So this is probability distribution of a binomial distribution. This is called probability mass function of binomial distribution. In this question, you are n is equal to 6. In this question, we have n equal to 6. And this is given at 0 is rejected if there are 5 or more heads in 6 tosses. So you have value of x greater than 5, that is 5 or 6. So your probability distribution will be fx will be equal to c6 c5, and your p is, if you have to reject null hypothesis, you have to accept the alternative hypothesis, and in alternative hypothesis p is 0.6. So 1 minus p will be 0.4. So into 0.6 raised to power 5 into 0.4 raised to power 1 plus c. You should go for the 6 also, because there are 5 or more heads. So there can be 5 heads, there can be 6 heads, into 0.6 raised to power 6 into 0.4 raised to power 0. So this will give you 6 into 0.6 raised to power 5 into 0.4 raised to power 1 plus 1 into 0.6 raised to power 6 into 0.4. When you solve this, this will come as 0.233. So probability distribution here comes probability of turning up head is 0.233, by which we can reject our null hypothesis. We will accept the alternative hypothesis and we will reject the null hypothesis. Your answer will be 0.233. Fine. Now this is data of household incomes. 24% of teenagers in India under the age of 18 live in household with income that are classified at a particular income level. So your population mean is population proportion, you can say, is 24%, which lives in a particular income group. Simple. Your n is equal to 400. So if the government data is correct, which of the following best approximate probability that at least 27% of teenagers in the sample live in household that are classified at a particular income? For finding out probability when you are given the proportion 24%, the formula will be P Z greater than, you have greater than 27, probability that at least 27% means your population greater than 0.7 probability, fx should be greater than 0.27. For that you have to calculate Z greater than. So for this you have formula, your sample mean is your, here sample mean is given greater than 27%. So sample mean you will take 27, that will be 0.27, probability will be 0.27. So sample probability of sample mean, probability of population mean divided by your standard deviation. Standard deviation here will be calculated from P into P minus 1 divided by n root. So you have to apply this formula. You have to apply population mean minus sample mean minus population mean, that is probability of population mean minus sample mean minus population mean. This will come, I will write this, this will come Pz greater than equal to 0.27, your P dash is 0.27, greater than 27% means you have probability of 0.27 minus 0.24 divided by your standard deviation. Standard deviation will become P is given 0.24, probability of having teenagers having in a particular group, income group is 24%. So P is 0.24, 1 minus P is 0.76. 1 minus P is 0.76. Fine. So you will have this 0.24 into 0.76, P into P minus 1 divided by n root. N is 400. So this should be your answer, and we will see that this is your answer. This is your answer. Probability of Z should be greater than 0.27, 0.24 divided by root 0.24 into 0.76 divided by 400. So the value of Z, this value of Z will show the probability that 27% of household have, at least 27% of household have income greater than the prescribed income. Fine. Next is what percentage of score falls within the 3 standard deviation from the mean. So you have to learn about the normal curve. So this is mean, and Z score gives you the standard deviation, how much your mean is, how much standard deviation your mean is away from your mean is equal to 0 from the center line, from the distribution z is equal to 0. Fine. So for example, z is equal to 1 represent around 68% of the area. You can see that z is equal to 2 is 95.45. z is equal to 3 means your value, z value lies between 3 and minus 3. So it covers the probability distribution of around 99.73. So your answer will be 99.7. You can see, and you have to learn this graph. Most probable question will come from this graph. You can see this 68.27. It is z value 1, this side. 2 deviation away, 2 deviation away, 3 deviation away, 3 deviation away. 3 deviation away gives you 99.73% probability or 0.9973 probability. Fine. Next is, such type of question are very common, where you have given a standard deviation and mean, and you have to find out the correct mean and correct standard deviation. In such type of question, you have to calculate sigma xi for correct total sum for the corrected figures and sigma xi square. These two things you have to calculate. So first we will calculate the total corrected sum. So you are given with sigma xi will be x mean into total number of observation, that is 40 into 100. Mean is given 40 into total number of observation are 100, so 4000. So corrected sigma xi will be 4000, and you have wrongly copied 50 instead of 40. So you will exclude 50 and include 40. So that will be 3990. So your corrected total of your observation is 3990. So corrected mean will be 3990 divided by 100, that is 39.9. It's simple. So mean is 40 and corrected mean is 39.9. You will fine. Next you have to calculate the corrected standard deviation. For corrected standard deviation, you have to find out ये आपको निकालना है. For that we will use the formula variance square is equivalent to 1 by n sigma xi square minus this. You have to find out this. We have given sigma xi, this is 5.1 square. 1 by n is 1 by 100. Sigma xi square you have to calculate. This is 40 square. 40 square is 1600. So we can calculate sigma xi square. So sigma xi square is 162601. This is sigma xi square. So now we have to correct this also. We have to replace 50 square with 40 square. So corrected sigma xi square is equal to 16260 minus 50 square plus 40 square. This is equivalent to 161701. This is the figure of corrected sigma x square. So corrected mean we have collected. Now we can calculate the correct standard deviation. So correct standard deviation will be sigma x square. So you have corrected sigma xi square, corrected 1 by n plus minus, sorry, minus, we will minus corrected mean, remember this, minus corrected mean square. So you have 1 by 100, 1 by 100, 161701 minus 39.9 whole square. So sigma x square is 25 and sigma x means your standard deviation will be 5. So corrected standard deviation is 5, corrected mean is 39.5. Fine. So answer will be your B. Answer will be B. Fine. Next is about your hypothesis testing. You are given with a city health department wishes to determine the mean bacteria count per unit volume of water at a lake, beach within the safety level of 200. A researcher collected 10 water samples. So this is the n is equal to 10. So your sample size is less. You you may undertake the measurements constitute a sample from a normal population. This is sample from a normal population. The critical region for test is alpha is equal to 0.019. So your confidence level should be 99%. Your confidence level should be 99% and your level of significance is 0.01. Alpha is equal to 0.01. Alpha is equal to 0.01. Fine. So for that you have n is less than 10. No population mean is given. No population mean is given. Variance is not given. So you will find out the t-score or t-test. And t-score should be less than t. 9 is your total sample is 10. So degree of freedom will be 10 minus 1, that is 9. And your level of significance is 0.01. This test should be this will give you your required result. So answer will be t less than equal to negative t. So your confidence level should be 99%, that is level of significance. Alpha should be 0.01 and degree of freedom should be your. Why we took the t-test? T-test, there are two reasons. N is less than 30 and no variance is given. So we will use t-test. Fine, we will use t-test. Remember, for this exam, just focus on properties and basic formulas. Now you have to find out the mode of a group data. For that, you have to first make this as a continuous frequency distribution table. For this you will do 50.5 and this will be 55.5. This will be 55.5. This will be 60.5. 60.5, 65.5, 65.5, 70.5. So this makes this frequency distribution class intervals continuing. And now you have class widths of 5. Class width is 55.5 minus 50 minus 5 is 5. So h is equal to 5. Now for mode we use the formula L. L is the lower limit of modal frequency. Modal class interval. Modal class interval is that interval which have maximum frequency. So this will be your modal class interval 60.5 to 65.5 plus f1 minus f0. f1 will be modal class frequency, f0 will be previous class frequency over 2 f1 minus f0 minus f2. This will be f2. This will be preceded, this will be success into h. H is 5. Calculate this. Lower limit of modal class 60.5. It will not be 61, it will be 60.5 plus f1 8 minus 7 2 f1 16 minus 8 4 minus 7. This is 7, this is 4 into 5. That is 60.5 into plus 1 by 5 into 5. So this gives you 61.5. So your mode is 61.5. Same way you have to learn about the median class. You have to find out the median class, and of group data, mean of group data, median of group data, mode of group data, measure of dispersion and measure of central tendency, regression, correlation, t-test, t-test, z-test. Basic properties of these will be very important for this exam. So this is the formula. Now you are given with two regression lines. Fine. Variance of x is given 12. Variance of y you have to find out. So first there will be three steps. First you will convert this into regression line. These two in regression line formula. You will convert these two in regression line formula. From that you will find out regression coefficient x on y and y on x. From that you will calculate correlation coefficient. These are the steps, and from that correlation coefficient you have formula bxy is equal to r into standard deviation of x over standard deviation of y. So you have calculated this, you have this variance of x is given, so you can find out the standard deviation of x. You have to find out this. These will be three steps. So how to do these steps? I will show you. This is nothing. This is very simple question. So x will be 5 minus 2y. Fine. So we can see this from. So first is your x plus 2y. Okay. We will do this from. You can find out from any of these, but we will first. Wait a minute. So here we can calculate y is equal to 5 minus x by 2, and this is, for this we will find out x is equal to 8 minus 3 by y 2. Why we done this? Because in denominator 2 is easy to calculate. Now you have y equal to 5 by 2. This is constant and this is the slope. Slope gives you the b y on x, and here we will get b x on y. So b y on x is minus 1 by 2, b x on y is minus 3 by 2. These two you have calculated. From this you will get r. R will be 1 by 2 into 1 by 2 into 3 by 2, and negative makes it positive. So this is 3 by 4, root 3 by 4 and root 3 by 2. R will be under root 3 by 2 and R will be negative. Why negative? Because your bxy is negative, bxy is negative, so R will be negative. You can see here. So R comes minus under root 3 by 2. First thing. Okay, we have calculated bxy and R. Now we know bxy is equivalent to R into sigma x over sigma. You can calculate from any things. We are calculating xy, this. So you have to calculate this. B on x on y is minus 3 by 2. Minus 3 by 2. Okay, and this. So wait a minute. So R is your minus under root 3 by 2 into sigma x, standard deviation of, that is under root 12 divided by minus 3 by 2. So when we solve it, it gives you 2. standard deviation of y 2, and variance of y will be 2 square, that is 4. Your answer will be 4. The value of statistic which separate the critical region and acceptance region. It is critical value. For example, value of z equivalent to 1. So it is you accept around 68% of your, the probability lie 68% of probability lies within your critical region. Outside your critical region, this is your critical region. Z, when Z is 2, critical value, when you are looking for looking for your probability distribution around 2 is around 95 or kind of fine. So critical value is the value beyond which you reject null hypothesis. Simple. Beyond which you will reject the null hypothesis. So it can be it depends on your confidence level what you take. If you take 95% of confidence level, so your alpha will be 0.05. so critical value beyond this region, 95% probability distribution, will be your critical value, will be your area where you will reject your null hypothesis. The value of test statistic that separate the critical region from acceptance region. So in this region you will reject your null hypothesis, and in this region you will accept your null hypothesis. The following observation 14, 19, 17, 25 constitute a random sample from unknown population with mean mu and standard deviation sigma. The point estimation of population mean. The point estimation of population mean will be sample mean, and sample mean you can calculate. So this gives you 23 plus 17, 40, 60, 95 by 5. 95 by 5, 19. So sample mean is 19. So your point estimation is of population mean is given by sample mean. In same way, point estimation of standard deviation, population standard deviation or population variance is given by sample variance. Fine. The sample mean is the point estimation for population mean. The sample standard deviation is the point estimation for population standard deviation. You have to remember this. Now for a distribution, the mean is 10, variance is 16, gamma 1 is +1 and beta 2 is 4. So beta 2 gives you kurtosis and gamma 1 gives you skewness. So +1 means it is positively skewed. Beta 2 greater than 3 gives you a highly centrical normal distribution, that is leptocuretic. When beta is 3, beta equal to 3 gives you normal distribution. Fine. And beta 0 gives you a platycuretic distribution. Fine. Which type of sampling is one where only the first sample unit is selected as random and remaining units are automatically selected at equal spacing? It is systematic sampling. It is systematic sampling. For example, you have to select 25 samples from population of 100. So what you will do, you will divide 100 by 25, 4, and you will find out first 1 to 4. In 1 to 4 you will find out your first sample. For example, you selected the third sample. Now automatically 7th will be selected, automatically 11th. This is systematic selection, systematic sampling of probability sampling. The chance of selection of every data point is same, but you choose in one way, that you are selecting 3rd, 7th, 11th. You can choose anyone, 1st, 5th, 9th or 2nd, 6th, 8th, 2nd, 6th, 10th, any, but this will be systematic. So this is called systematic sampling. Fine. Next is a significance test based on small sample may not produce a statistically significant result even if the true values differ substantially from the null value. In such cases, we make the type 2 errors. Why? Because type 2 errors, because you have small sample size, but you select the null hypothesis falsely, because this is due to two reasons. Either small sample, your sample is very small, fine, first thing, and it is highly distorted data, fine. So you will make type 2 errors. Type 1 and type 2 errors are when you type 2 error is type 2 error and type 1 errors. So type 2 error, false negative, occurs when null hypothesis is not rejected. You select null hypothesis even though it is false. Type 1 is you reject null hypothesis. Reject null hypothesis even if it is correct. Fine. That is type 1 error. The confidence level or confidence for a confidence interval for a mean is the probability the procedure provides an interval that covers the population mean. For example, this is the probability. For example, 95% of confidence level gives you an interval of Z lies between 1.96, negative 1.96 and 1.96. So these are class intervals. These are class intervals, and this provides the probability that population mean lies within this class interval. And probability, for example, here probability is 0.95. Fine. So answer will be D. The suitable formula for computing the number of classes, it is 1 plus 3.322 log n. N is your total population. N is represent your total population. Total n. So this is called Sturge's tool. Sturge's tool. It gives you the number of classes you can, while making the frequency distribution table, you can select the number of classes, and it is given by 1 plus 3.322 log n. You have to remember this. Just learn it. One problem with hypothesis testing is a real effect may not be detected. This problem is likely due to effect is small and the sample size is small. This is the main reason. This is the main reason. The effect is small and the sample size is small. So it will not be distributed normally, and hypothesis testing will result in either type 1 or type 2 errors. Now this is box plot. So box plot gives you, this is Q3, this is lowest value, this is highest value, this is Q1, this is Q2. Fine. So lower quartile is, this is lower quartile, Q1 is lower quartile, Q1. So Q1 you can calculate, this is 15, this is 3, this is 6, this is 9, this is 12. So lower quartile is 12. Your answer will be 12. Option. When successive midpoints in a histogram are connected by straight lines, the graph is called frequency polygon. So you have midpoints of your histogram and you connect those midpoints. This gives you frequency polygon. This will give you your frequency polygon. Frequency polygon, we connect these points directly, not with freehand. If the mean of a certain set of data is 16 and variance is 4, then find out the coefficient of variance. So coefficient of variance will be calculated by coefficient of variance is standard deviation over mean into 100. So variance is given 4, mean is 16. So unroot 4 by 16 into 100. This gives you 12.5. So your coefficient of variance will be 12.5. So you have to remember this formula. Coefficient of variance is standard deviation over mean into 100. This is used to check out the variability of two data. Check out the variability of two data which have same mean and which have same mean. For testing the correlation coefficient, we use t-test. T-test, when evaluating the significance of correlation coefficient, t-test is the appropriate. We can use Z, but most appropriate is t-test. Z-test is for comparing, means when population variance is non and it is not typically used for correlation coefficient. F-test between various groups, and chi-square test for categorical data, like which have qualitative data, not quantitative data. Categorical data, for example, hair color. So you have different shades, you have brown, you have black. For such type of data, we use the chi-square test. It is non-parametric test. This is parametric test, this is parametric test. Fine. So this is all about today's session. Thank you so much.